There are millions and billions of stars in our universe. Sun is one of them. What our ancestors knew on a fundamental level was that the sun provides a vital ingredient for most of the life on Earth. Without the energy provided through sunlight, vegetation cannot grow, and without vegetation animals do not have a source of nourishment. However, what we know today that our ancestors did not is just how far-reaching the scope of the sun's influence is. The sun is what is known as a main sequence star. That is, a sphere composed primarily of the two gases hydrogen and helium such that certain conditions are met. The size of the sun compared to the largest known stars, red giants, is not very big. However, if compared to the most common type of star in the universe, the red dwarf, the sun is quite a bit larger. At about 864,000 miles or 1.4 million kilometers wide, the Sun is 109 times wider than Earth, and it accounts for more than 99.8% of the Solar System's total mass. The rest is split between the planets and their satellites, and the comets and asteroids and the dust and gas surrounding our star. Over 1 million Earths could fit inside the Sun. If you were to fill a hollow Sun with spherical Earths, somewhere around 960,000 would fit inside. However, if you squashed those Earths to ensure there was no wasted space, then you could fit 1,300,000 Earths inside the Sun. The surface area of the Sun is 11,990 times that of Earth. The planets in our solar system orbit around the Sun. Even at this blazing speed, it takes the Sun approximately 225 to 250 million years to complete one journey around the galaxy's center. This amount of time, the time it takes us to orbit the center of the galaxy, is sometimes called a cosmic year. The Sun is different because it does not all rotate at the same time. The gases and plasma near the Sun's equator rotate around the Sun's axis every 25 days. As you move towards the Sun's poles, the rotation speed slows. Near the North and South poles, the Sun rotates once every 36 days. That means the Sun's poles take 11 more days to rotate around the Sun's axis than its equator. The differing speeds of rotation is called differential rotation, meaning different parts rotate at different speeds. The Sun looks like a burning ball of fire, but it actually has an internal structure. The visible surface we can see is called the photosphere, and heats up to a temperature of about 6,000 degrees Kelvin. Beneath that is the convective zone, where heat moves slowly from the inner Sun to the surface, and cooled material falls back down in columns. This region starts at 70% of the radius of the Sun. Beneath the convection zone is the radiative zone. In this zone, heat can only travel through radiation. The core of the Sun extends from the center of the Sun to a distance of 0.2 solar radii. This is where temperatures reach 13.6 million degrees Kelvin, and molecules of hydrogen are fused into helium. Sunlight takes almost 8 minutes to reach Earth. The Sun is an average distance of 150 million kilometers from the Earth. As we know, light travels at 300,000 kilometers per second. Dividing one by the other gives us an approximate time of 500 seconds, or 8 minutes and 20 seconds. Although this energy reaches Earth in a few minutes, it will already have taken millions of years to travel from the Sun's core to its surface. The Sun is the most perfectly round natural object known in the universe, say scientists who have conducted precise measurements of its dimensions. As a spinning ball of gas, astronomers had always expected our nearest star to bulge slightly at its equator, making it very slightly flying saucer-shaped. Although we think of our Sun as a unique celestial body, it is, in fact, one of trillions of stars in the universe. On top of this, the Sun is rather ordinary as far as stars go. The official classification for our Sun is GV star, often referred to as a yellow dwarf star, which means that it is a main sequence star whose surface temperature is between 5,027 degrees Celsius and 5,727 degrees Celsius. We know that oxygen is required for burning. In space oxygen is not present. So how does sun burn? The sun does not run out of oxygen for the simple fact that it does not use oxygen to burn. The sun survives by burning hydrogen atoms into helium atoms in its core. In fact, it burns through 600 million tons of hydrogen every second. The sun is responsible for 45% of the tidal forces generated on Earth. High and low tides are caused by sun and moon. The sun's gravitational pull generates something called the tidal force. The tidal force causes Earth, and its water, to bulge out on the side closest to the sun and the side farthest from the sun.